All right, so our lesson today is on radical expressions and rational and irrational numbers, which to you should probably just sound like a whole bunch of math words. So radical expressions, anytime you see them, that's anything with a square root, or you may have a cube root or a fourth root. All right, it's anything with that radical symbol. And radicals are the opposite of exponents. And what I mean by that is if you have like 3 squared equals 9, then to say the opposite is the square root of 9 equals 3. Or you could have, 2 to the 4th equals 16, or the 4th root of 16 equals 2. Now, one thing that is implied that you probably need to really make a note of here is that when you write square root, that's the opposite of squared. And so secretly, there's a little 2 right there. That's going to be important here in a minute. All right, and then rational and irrational numbers, that's just a certain type of number, but rational numbers are, this is not a good definition, it's all your easy numbers, fractions and whole numbers, and most decimals, so fractions, whole numbers, and most decimals. Irrational numbers, just like irrational people, are crazy. So we've got pi, that's the most common irrational number. Any decimal that goes on and on without repeating, that is also irrational. And the last thing we're going to look at today, any numbers that have square roots in them that do not break down are irrational. For example, the square root of 2 is an irrational number. The square root of 9 is rational because square root of 9 equals 3, just like we said. All right, so let's look at kind of what we're going to do with these 2 pieces of information. Okay, so simplifying radicals really just require 2 steps. The first step is we need to make prime factor trees, which you have maybe not done for quite some time, but they're very easy. And then the next thing we're going to do is look for groups, and I'll explain that when we do our first example. All right, so this first example, the square root of 18. So remember, the square root of 18, there's secretly a little 2 right there. That's going to come in handy in just a second. So we're going to break 18 down into prime factors. So that's 2 times 9. And anytime I get to the end of one, I always circle it just so I don't lose it. If I break 9 down, that's 3 times 3. Okay, so that gives me the square root of 2 times 3 times 3. Now, the reason this squared is important is it means I'm looking for something that would have an exponent 2 or be a group of 2. So there's 2 3s here. And when I see that, I know that I need to pull that out to make a whole number. So for square roots, groups of 2 make whole numbers, which is going to make my final answer here 3 square root 2. Now notice this 2 is still stuck inside of here because it doesn't have another 2 to partner with to make a whole number. So just groups of 2 can come out to make a single whole number on the outside. All right, let's look at the next example. So I'm going to break down 24, 2 and 12, and you could break this down a different way. 2 and 6, 6 is 2 and 3. All right, so I'm going to write out, I've got the cube root this time of 2 times 2 times 2 times 3. So notice this time, the example says that I'm looking for the cube root. That means I need 3 of something to make a group. So I've got 3 2's here that will come to the outside. So my answer is going to be 2 cube root of 3. That 3 is stuck in there because it doesn't have anything to make a group of 3 with. Notice also that with cube root, you do have to write this little 3 that kind of goes in the nook of that square root symbol. All right, last one. 196. So if I break that down, let's see, that's going to give me 2 and 98 and 2 and 49. Now, I tend to just do 2's first so I can get smaller numbers more quickly. 7 and 7. So that's going to give me the square root 2 times 2 times 7 times 7. Now notice this time I'm not writing the 2, but secretly square root means I need groups of 2. So I've got one group, another group. So that means a whole number 2 is going to come to the outside and a whole number 7. And this is all multiplication. And there's nothing left on the square root symbol on the inside, so I'm just going to leave it as 2 times 7, or really this is 14 as my final answer. Okay, so make sure that first of all you understand how I'm getting these final answers. If you need to go back and rewatch the video or write any questions that you're going to have, maybe do that right now. All right, the second part of our lesson then is to talk about rational and irrational. So when we talk about rational and irrational, remember anything irrational has a square root left in it. So for example, this first one, 3 square root 2 is an example of an irrational number because it still has the square root symbol. The same for 2 cube root 3, it's also irrational. 14, however, is a rational number because the square root went away. All right, and then simplifying our radical expressions. I just want to show you some things you can do when you see these problems in context to simplify your answers. So in this first example, multiplying, since radicals are all about exponents, which means they're really all about multiplication, we can combine multiplication problems. So that means we can treat this, break our 15 down to be 3 and 5, and we can treat this as one big square root. 3 times 5. So the first 3 is coming from this first square root. The other 3 and 5 are coming from the 15. And then we can do what we just did, right? Pull out a pair. This one is groups of 2 because it's square root. So my answer is 3 square root 5, and that is an example of an irrational number. All right, on the second one, you can kind of think of square roots once you get them as variables. So these are like terms because they have the same square root. And it's not just that they're square roots, they're both the square root of 3, which means I can combine these. So think about a similar problem. If this had said 2x minus 7x, I think all of you understand that you would get negative 5x. So in that same concept, you're going to get here negative 5 square root 3. All right, try to kind of follow that example and see how those are very similar. And because there's a square root symbol left in the answer, this is an example of an irrational number. All right, our third example down here on the bottom left. So thinking about the example we just did, this has a square root. Oh, and I should make that a better example. Let's change that to, let's make that, I don't even want it to be an 8. All right, I'm going to go ahead and change that one to a 5. So notice that the 4 has a square root 5, but the 8 doesn't have anything. All right, that's like saying 4x plus 8. Can you do anything to simplify that? No. So the answer, if you had to simplify, is just the same thing, 4 square root 5 plus 8, or you could say already simplified. And now that in itself, you should see there is still a square root symbol left. In the entire expression, there's still a square root there. So the whole thing is considered irrational. All right, our last example is a little tricky, but it's the most important one. Here, you can divide whole numbers, but you can't do anything with square roots. So there are 3 whole numbers in this example, and we have to think, what can we divide all 3 of those by? And we can divide all of them by 3. Notice I'm not touching the square root at all because I can't do anything to it. Whatever the square root is stuck underneath the square root. So when I simplify that, I'm going to get 1 minus 3 square root 6. And we could put all over 1, but anything divided by 1 is itself. So this is the simplest way to write that. All right, that's because I'm dividing all the whole numbers. And because that still has a square root symbol in it, that's an example of an irrational number. All right, you really may need to rewatch parts of this, but this stuff that we're doing is so important for what we're going to do next week on Monday. And this is a very quick summary, but you need to have understood all the examples, or at least tell me where you're not sure about before we start our new lesson on Monday.